especially the way it's like worded out, here saying P is bigger than 7 and all this. So they ask us to determine the equation of a tangent to this circle. So what we're saying is that with any circle, right, they will be giving you the way the equation is laid out, they will be giving us some pieces of information. So for example, here, they are giving us what we know is any circle. This is the standard form, you see. So whatever this is the 13. So r squared is equal to 13, meaning that r is actually square root of 13. You see, that's the radius. And what else have they given us just from giving us the equation of the circle?
Yeah.
Pardon?
Same. Square root of 13 will be just square root of 13.
Yeah, true, 100%. So in this format, right, what does A and B tell us about the circle?
Those are your coordinates. You're saying, isn't that your center?
Yep, it's the center. So in this format, you can see there's x minus 7, and then here there's y squared, meaning that there's y minus 0 technically. And then here you have like 13, you see. So the big idea here is, remember, you always take the opposites of what you see in here. So this is going to be a 7, coordinate 0. This is going to be the center of the circle, right? That's the center of the circle. And we say the radius is like square root of 13, of which square root of 13 is just below 4. So here it says determine the equation of the tangent to this circle at this point where P is a number that is bigger than 7. So you can imagine, you have to remember the reason why they're telling you that P is bigger than 7 is because with a circle, right, a circle will always have 2 tangents every single time. For one tangent, a circle will always have another one. And this is what I mean. If I have a circle, right, remember the whole idea with the tangent to a circle is that it will touch the circle at a certain point, and that line has a certain gradient. So for example, if you have a tangent here, try and do it nicely. If you have a tangent here, whatever the gradient is here, right, you have the exact same tangent on the other side here, you see. So if you had, let's say, a tangent over here, like this, oh goodness, like this, you'll automatically have another one on the other side. Do you see that?
Yes.
And it's like that for every single point on the circle. Where there's a tangent somewhere, there'll always be another tangent on the other side. So with our specific circle, the reason why they're giving us that, the reason why they're telling us that P is bigger than 7 is because they're trying to give us an idea of where this X value is. Because firstly, if you look at your circle, what we already know is this center, the X value is a 7, the Y value is a 0, see. So if you want to draw it on a Cartesian plane, I mean, like whether we like it or not, it's going to look something like this. There's going to be your x-axis here. Yeah, it doesn't look straight at all, and it's kind of annoying. Whew, this one doesn't look straight either. Oh goodness. Well, let's just hope. Okay, it's fine. So this is like your x-axis, right? You have an x-axis here. Now you have a y-axis here. There's a coordinate here. This is where the center is. Don't worry about the x-axis actually. Let me actually write it out so that we show that it's really not necessary. What's necessary here is to know that our tangent, right, whatever its gradient is, we don't know. But what we know about our tangent is that it touches our graph where the x value is above 7, meaning that, remember, this is the point where the x value is 7. So to the left, that's where you have x values that are below 7. To the right, that's where you have x values that are above 7. So do you see that this is just trying to tell us that the tangent is on the right side of our circle?
Yeah.
You see? Yeah, that's why this is given. Now they said that it meets the graph at -2. So if this is like a 0, if it's going to meet, so this is where you need to use logic, right? And now square root of 13 in the calculator, what does it come out as in decimals, two decimal places? What is the answer?
3,605.
Okay, so let's just 3,61. So if you look at it nicely, the distance from the center to this point, remember this is going to be square root of 13, right? Which is the 3.61. So if this y value is a 0 here, downwards, this y value is like -3 something. Do you see?
Yes.
Yeah. So if your graph is going to touch, if your tangent is going to touch your circle where the y value is a -2, I mean, technically speaking, you want to think to yourself, okay, fine, if the 0 is this line here, it means that -2 should be somewhere here. You see, because
Yeah.
if there's -3 point something here, it means the -2 is just somewhere there. So if the tangent is going to touch the circle somewhere where the y value is a -2, we know that it can either touch it over here, which is the left side, or it can touch it over here, which is the right side. And based on what they told us, it has to touch it on the right side of the center. You see, so we automatically know that whatever our tangent is, whatever we're looking for, it's a line that's going to be somewhere here. You see. Now we haven't even started trying to do any math. We are just working with the given information, which is how you want to work out these questions. Because what we're doing now, we're not like just explaining the question, we're actually figuring it out. And the way we figured it out is by using the information that they gave us. Like, be very comfortable taking something they've given you and making it your own. Like, use it. You see here, we used everything. We literally like milked every single piece of information, the center and the radius, because those are literally the key things with the given equation anyways. Those are the things that they're giving you. So anything they give you, make sure you use it as much as you can. So what we now know is that there's a p value here and a y value of -2. So the tangent means the circle here. Now, this is where getting the equation of a tangent now comes in, because when you get the equation of a tangent, it's basically a method that you use. Now, the method that you use is not difficult. Now, this is what I mean by the method is not difficult. Anytime you need to get the tangent to a circle, you need two things. You need one point. You need firstly the center of the circle, and then secondly, you need a point of contact, which is somewhere here. Because what you actually do is, for you to get this equation of this tangent, remember, an equation of a tangent is just y is equal to mx plus c. But then what we know is that to get the equation of a straight line, you can start with this format, right? It's going to, you'll be able to like get your equation of your circle. Now, the big idea is here, we at least need a gradient first. Now, the issue here is that we don't have a gradient. Like, we don't have two coordinates to use to get, because normally what you do is, instead of just diving towards getting this gradient, what you actually do is you get the gradient of this perpendicular line and then use this formula, y m1 times m2 is equal to -1. You use this formula to then get the gradient of the tangent. Does that make sense?
Yes, it does.
Yeah. Cool. So this question is quite packed, and I think that's why it's a good question, because now we have an issue. We cannot get the gradient here because we don't have the two coordinates. But the fortunate thing is we have the distance of the center until this point. The distance from the center until this point, it's just our radius, right?
Yeah.
Yeah. So our first problem here, before we can even worry about the tangent, is that we don't have p, and we need p. So what we're saying here is we can get p using the distance formula. In our distance formula, we can just sub in the information that we have and then work out the variable that is missing, which is just going to be one x value there. So just from what we're doing, this should highlight the fact that with all math questions, never focus too much on the main question. The main question should create for you smaller questions. And then you work out those smaller questions first. And then after working out those smaller questions, you'll be fine. So here, distance is square root of 13. Here we can just say 7 minus p. Let's do that, 7 minus p. And then here we can just say 0 minus -2. It's going to be a plus. we can square both sides. And then what? This is gonna be like 13. And then remember, you don't have to like worry about rewriting everything because I'll just send it to you when we're done. I know these days I always forget, like, ugh, terrible. But I will just make sure I always send the stuff before we like finish or end the session. So this is like 7 minus p, and then another 7 minus p. This is like a 4, 13. This is like 49 minus 7p minus 7p as well, plus p squared. And remember, if I write down anything that's like a bit weird, just let me know so that we can like fix it. So let's put this in standard form. This is going to be squared negative 14p here. So here it's going to be like 49 plus 4, which is like 53. 53 minus the 13 and give us a 40. See, we just said 49 plus 4. That's like 53. 53, if we're going to subtract 13 when it goes over to the other side, we're going to end up with like a 40. Now, this one we have to be careful. Factors of 40 that can give us a 14. There's like 40 and 1, 2 and 20. This one is a bit tricky. It's also a bit odd. It's making me think to ourselves, this one is, it's a bit strange to have a p-value here. But I mean, let's maybe use the quadratic formula. But if there's something fishy in this question, you'll just let me know. You'll just let me know, because yeah, man, the mistakes, they happen all the time. But let's see what this says. P is equal to minus b plus minus b squared minus 4ac over 2a, right? And then p is equal to minus b plus minus b squared is like negative 14 squared. And then minus 4 minus 4a, and then c is like 40. The whole thing here over 2a. A is like 1. What does this give you?
I'll take it down.
Excuse me.
Double
I'm sorry.
checking.
I am sorry. I
Okay.
am.
No, you get 40, Levi. I don't see a mistake anyway. By the p
Okay.
minus 14 plus 40.
And then what about putting this in the calculator? What is the value of p? Because we should at least get something that is bigger than 7 as an x value. And then, no, dude, we just took the long method to get p. The other easier method to get p is to just throw it into the equation of the circle. Yeah, I feel like this is actually obsolete because it's also a bit of a risk. The easier method is to just use the equation of the circle, because the equation of the circle already has everything we need. We can just throw in, remember the x value is p. We have this coordinate, right? There's an x value and a y value. It also touches the circle. So in the equation of the circle where x is, we can put a p. Oh, it's the distance formula. Aga, same thing. It's gonna come out. It's just gonna come back around, because you see here, this is the equation we would end up with from here. Funny enough. So it's all the same. Oops, man, I thought I was onto something. Anyway, so what is this giving us?
Almost there.
Cool stuff.
Sorry, I'm just fixing it. Otherwise, it will be.
Yeah, I mean, like, take your time. Take your time.
Okay, so I get 10.
And oh yeah, 10 and 4. Baga. That was so dumb.
Yeah.
That was really, really, really dumb. I feel Snap. I literally stopped at 2. Oh no. This is just weird. Okay, so I think if you factorize here, it's just gonna be quicker. Ugh, my brain. My brain is still waking up, but it's like 6. Goodness. So 10 and 14 wolf. 10 and 4. Negative 10, negative 4. Wow, it's so weird, dude. I wasn't even thinking. Like legit. So let's see here. 0 is equal to p minus 4. P is equal to 4. P is equal to 10. So obviously P cannot be equal to 4 because that would be on the left side, you see. We want P to be bigger than a 7. So we have to pick this one. Cancel that one. So here we can now say, therefore, the gradient, we can use these coordinates, right? We can use these coordinates here. Got this to be a 10. So we can just get the gradient, you see. You can say negative 2 minus the 0, blah, 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 blah. Negative 2 minus 0 over 10 minus 7. It's the gradient formula. So this is going to be negative 2 over 3. That's the gradient of the white dotted line. You see, it's a negative gradient. Now, since we have gradient of that white line, we can then say, therefore, negative 2 over 3 times the gradient of our tangent is negative 1, of which if you divide by, yeah, if you divide both sides by this, you're gonna have this fraction flipped over with a positive now. Perfect. So our tangent is practically done now because look, y1, the x1 here. We have a coordinate that the tangent passes through. It's 10 coordinate negative 2. So we have 10 here, negative 2. This is practically x1 and y1. And we have our gradient, you see, so we can just say y minus negative 2. And then our gradient is like 3 over 2 x minus 10, right? And then here you have like 3 over 2x, negative 30 over 2, and then like y plus 2. And then what you got now? So it's like 3 over 2x, negative 30 minus 2. What is that gonna give us? Yeah.
Times 3 over 2 times negative 10, I get negative 15.
Oh yeah, because it's rounded off. Yeah. I mean, because it's simplified, sorry. So yeah, it makes it easier now because it's like negative 15 minus 2, which is negative 17. Oh yeah. So this kind of doesn't look too bad because you see, if this is like our tangent, clearly, and a y-intercept of like negative 17 somewhere down there makes sense because, you know, this is like going down. So negative 17 would be somewhere down there as a y-intercept. So yeah, it's fine. I mean, like would have maybe an x-axis, a y-axis somewhere here. So negative 17, yeah, it looks accurate as a final answer. I hope it makes sense.
Yeah.
Yeah. So let me see here. So yeah, we can make this. We can stop this one so that